So one of the big ideas in fractions was this idea of times on top, divide on bottom. Okay, so any factors that we have on top are times factors, any factors that we have on bottom are divide factors. So this idea of times on top, divide on bottom is a really easy way to keep track of things with fractions because there's only two choices. It's either times or divide. Okay, so when we're simplifying with multiplication, we can use this idea. Okay, so when we had these fractions that we need to simplify to lowest terms, 10 over 15, we did a divide 5 to get here. But we also can show that divide 5 as a factor of 5, as a times 5 going the other way. So 10 is 5 times 2, 15 is 5 times 3. That common factor is 5, what we're trying to get rid of when we simplify these fractions. Okay, so we have a times on top, divide on bottom. Well, times on top and divide on bottom undo each other. Okay, and every time you undo something with multiplication or division, you're left with 1. Okay, so that's called a multiplying identity. Okay, so anytime you undo with addition, subtraction, where you're left with 0, when you undo with multiplication, division, you're left with 1. That's important. Okay, so we're going to end up with 1 times 2/3, which is 2/3. Now, whenever we see times with fractions, really, well, fractions are all about times and divide. Well, if they're all about times and divide and we're timesing, we're just doing what's already there, times and divide. So when I look at fractions like this, I don't see two fractions. I just see one big fraction because times on top, divide on bottom. That's it. And it doesn't matter that it's 3 times 5 over 5 times 4. I still have a times 5, a divide 5. Well, it doesn't matter if they're diagonal like this or right above each other like this. Because it's times, and I'm seeing this as just one fraction, one big fraction of times and divide, I know that I have my times and divides in the right spots, so I can just cancel out times and divide like this and end up with 3/4. Now, the way I learned how to do this when I was in elementary school was, well, I have times on top, divide on bottom, could just cancel out like this and just multiply straight across. Use my top times top, bottom times bottom. Okay, now that could be, you can look at it that way. You can look at the way I'd look at it, where it's just, I ignore the times there. If I'm combining fractions with times, it's just one big fraction. 3 times 5, 5 times 4, those common factors cancel out. I'm left with 3/4. So I can do this with any fraction. So when I see a fraction like this, all I see is just times, so it's just times on top, divide on bottom. And any times and divides that match, they will cancel each other out. So I see I've got a times 7 here, divide 7 here. Those are going to undo each other. I see a times 3 here and a divide 3 here. Those will undo each other. Now, it's important to show those pieces. So I'm going to do 14 as 2 times 7. I'm going to show and I'll do that over 3. And I'm going to show the 15 as 3 times 5. And 21 is 3 times 7. Okay, now it doesn't matter which ones I cancel. That's a times 3 divide 3, or I can times 3 divide 3. Doesn't really matter. Okay, and it doesn't matter which order it's in because I know times. Doesn't matter which way I organize times, it's all the same. So this times here and this divide here, they're going to cancel out. Okay, as long as I keep track of one with one for one times with one divide, one times with, now I have a choice here, I'm just going to use this one, but it doesn't matter, as long as I just use one, that's perfectly fine. So then what's left over is top. I just combine everything, the times on top, and I just have the one divide on bottom. Times on top, divide on bottom, and we know that times and divide cancel each other out. Okay, so here's my final simplified answer. Now I could have, okay, now this would be a long way to do it. I could have done 15 times 14. Okay, so that's 210. I could have done 3 times 21, and that's 63. And then I could have simplified this answer. Okay, I know there's a common factor of 21, so divide by 21 to get 10, divide by 21 to get 3, and I get the same answer there. However, to avoid dealing with these big numbers, we can just cancel out common factors as we see them. So this is the same thing here. I see common factors here. I see a factor of 3 here, factor of 3 here, factor of 3 here. Now one of them will cancel out with one of these. I see a factor of 5 here, right? That should cancel with a factor of 5 here. So let's write this out. So I'm going to write this out as 3 times 4 on top over 3 times 5 on bottom. Okay? And again, this is just going to be, I'm just going to move this out of the way for now. Okay? I'm going to write the 20 over 27 as 4 times 5. Now I could use a 2, but I can see that it's going to be 4s that I need and 5s that I need. And I'm going to write this as 3 times 9. In fact, I should probably just leave that as 27 because that 3 is already going to take care of that 3 there. Okay, so then all my times are on top, divide on bottom. That's it. I don't need to think of this as two separate fractions. It's all times on top, all divide on bottom. Okay, now I'm going to cancel some things out. Times 5 divide 5, times 3 divide 3. Those undo each other. Well, I'm left with 16, although they're common, they don't cancel out. Okay, because they're both on top. And then 16 over 27 is my simplified answer. And I know that's simplified because there's no more common factors involved in the top and bottom that I can cancel out. Okay, so this one here, again, I'm just going to draw it as one big fraction. Okay, now you don't have to do this. You can do this as 3 different fractions if you like, but it's good to recognize your common factors. Okay, there's a common factor of 9 here, so I'm going to write that as 9 times 3 on top, and 5 is prime, so I'm just going to leave it as 5 on bottom. There's 8. I need a factor of 2 here. Okay, that's going to cancel out, so I'm going to write the 8 as 2 times 4. And I know the 45 is going to be 9 times 5. And then 1 and 2. Okay, those are simplified already. Okay, they're prime. So I'm just going to leave it like that. Okay, so what cancels out? Okay, again, times on top, divide on bottom. Times 9, divide 9. Times 2, divide by 2. Looks like that's all that cancels out. There's just factors of 5 and 4. So I end up with 12 on top, 25 on bottom. So that's my final answer here. Okay, so this idea of times on top, divide on bottom, and times and divide undo each other is a very simple way of thinking of fractions, especially when we understand fractions as times and divide. If I'm multiplying, I can just think of just as one big fraction of times on top, divide on bottom. Okay, so here's some practice ones. Okay, I want you to do these on your own. I'll show some solutions for these, for the harder ones anyways, but these are ones that you should work on your own.